Welcome back, everybody. So I have these jobs that I've been doing. These parts are just way too long for my mill. So these are the holes that need to go in the ends, and I actually have two other parts also that need holes in the end. So I came up with this idea that I'm going to make a fixture that is going to mount to my hand drill right about here, around this diameter, and we are going to lock the spindle in my milling machine, and we are going to do some side drilling. So first things first is we are going to design this part on Fusion 360. So I'm going to design it. It's going to fit in a regular holder, and if I really like it, maybe I'll post them on eBay to sell. Gotta load parts in between, that way still staying productive. But these ones are actually getting a hole in the ends too. They're getting two holes here. So, I don't know. Honestly, I just didn't want to drill. Well, let's see. Those ones, there's 80 parts. Each one gets 4. So 8, 16, 12. That's 320 holes that need to be drilled and tapped. So I would much rather take a little more time, make a fixture, and do them in the machine. I was gonna have to make a fixture anyways, so I figured I might as well make a drill fixture that's gonna hold the drill. In theory, it should work, but you know, it's like, in theory it should work, but I have to program it by hand because the only can cycles that we have is for, yeah, let's see what this thing's doing. So the only can cycles move the Z. So I gotta figure out what we're gonna use for this drill fixture. So this is the fixture I have. It's not a drill fixture. Fixture to hold the drill. So what we're gonna do is make this diameter the same size as the drill diameter here, and we're gonna saw cut this. I'm gonna have a recessed bolts that's gonna hold here, and this is gonna float. So I need to figure out what size. I want to try to go with like a 3/8 bolt or something decently sized. So we're gonna go see what we have in our junk drawer. If not, we'll have to run to Home Depot another day. So we have 1/4-20s here, which are way too small. I mean, I want something strong, but I need a cap head too. Yeah, something like this, but just way bigger would be perfect. So let me see here. So something like that would be good. Oh yeah, that'd be perfect. That's 3/8 also. Let's see if I can find another one of these. Best way to see if threads are the same, you can line them up like this and put them up to the light. And these ones look, yeah, they look like they do line up. These actually, yeah, perfect. So yeah, we'll use this. Or should I go with the longer ones? If I have 2 of them, I do. Probably should try to go with the longer ones, but we'll see which ones we can use. Obviously the longer, the stronger the thread. So I think first thing to do would be, so this length from here to here is 2.5. So that would actually be be perfect. It would use almost all of the length. Yeah, and this is 370. So this hole is, it should be 1 inch, 1 inch 693, and this from here to here is 2.5. So let's get our calculator here. So 2.5 minus 1.693, so that means it's 800 thousandths divided by 2. So that means it's 403 thousandths from here to here. And this is 365. So I actually think I'm going to make this 3 inches instead. That way it's stronger. Shouldn't affect anything with the drill. So all we do here is we go to press pull. And we're gonna make 250 thou bigger on each side. I love Fusion. It's very simple to use. Once you get used to it, we should probably add on the bottom too. So press pull. Gonna add 250 there also. And I guess we'll try to add it to this face also. Might as well just make the whole thing big and beefy, you know? What's going on here? So press pull. Let's see what that does. Okay, that made it way bigger. I don't know what happened. Not really sure what just happened, but let's try that again. New offset. Okay. Okay, so yeah, that works. Get to this side. We're gonna have to extend this a little more too. This is our shaft that we're gonna be holding with, so we'll extend that too. That's a 750 diameter. I figured that'd be enough. So yeah, there it is. Now we have more here, so now we know that this is a 3/8 drill. So let me finish putting these in there. We'll get this in the machine and going. All right, so it's 4.5 inches that way and 3 inches this way. I found this plate that is exactly 750 thick. So we're just gonna use that. I'll take a skim pass to make it look good. But yeah, we're gonna put this on the saw, cut it off, and we'll square it all up inside the machine. I think it's pretty heavy. Let's change this. These are the days that we'll want back. Alright, so it's gonna be a little sketchy, but it'll be alright. Might just cut it all the way through. We'll do the 3 inches, then I can just cut it the other way after. So we're gonna cut a little oversized because who knows if it's gonna be cutting straight. Probably not because of how far high it is. So all we need is like, yeah, like maybe like 3 let's do like 3.2, 3.3 is good. So gonna go in a little more. So like right there maybe. All right, let's see what this thing does. Let's tighten this bad boy down. I do have that nice saw over there, but I don't want to ruin the blade and stuff. All right, let's see what happens here. Definitely a little sketchy. So I do have, I'm gonna get some coolant for this thing. All right, we're getting some flow of coolant now. So let's see what we can get going here. Let's slow that down a little. No need it pissing everywhere. It should cut pretty good. It's mild steel. I think it's not 303. Might be 3. I think it's 303. No, it's not stainless. I don't even know what kind it is, man. Whatever, but it's cutting. Alright, so something I didn't take into consideration is the height of this. So this is as much as I can cut, because it's hitting here. See? So, we're gonna do something else. Probably what I should have done from the beginning, but it's alright. We just laid it down. Now we're cooking. So. Done soon. All right, so for a Harbor Freight bandsaw from Central Machinery, definitely not bad, man. Not an expensive saw. It's cheap, but I mean, things cutting steel, no problem. Check that out. That's a heavy hunk of metal. Alright, so here we are. It's supposed to be 3 inches. It's very oversized. So we're going to be removing a lot of material by 4.5. So that's like 400 something thousandths big. So first we're going to square it all up. And then after it's squared, then after it's all squared up, I can put it back in the mill. I'll probably rough out these corners to match, get rid of all this in the machine. And then after it's all squared up and everything, and I do these holes for the screws, then in the counter and the bore, I'll stand it up. Gonna walk around and make a nice circle there to hold it inside of one of the collets, one of the tool holders. Final pass. Barrage. All right. Nice squared up piece of metal. Four inches 3/1000ths. 4 inches 3/1000. 4 inches 502. 4 inches 502. It's not the best finish, but definitely good enough. Here's the part, the material, just like this. Just do adaptive clearing. I'm gonna use the 1/2 inch end mill. This is just gonna rough it, and then I'll also have it finish the bore. This is low carbon steel. We'll still do high carbon though. The mini mill is not the most rigid machine. Step overs, optimal load, we'll put 50 thou. It's gonna run for a bit, but we'll leave 20 thou on everything. Let's see what it does here. It's generating tool path. So it has a ramp. It ramps down into the hole. So looks pretty good. It roughs everything out for me. It ramps the hole. Leaves 20 thou on everything. You can actually watch it and simulate it. So here comes the end mill. Pass. It's gonna do all the passes. I'll fast forward a little. Good, ramps in, does that. Okay, it's done. Let's see what. So that runs for 29 minutes. That's too long. I think the ramping is the highest amount of time. So I'll try. I'm gonna put a drill first. Here we are. It's all cleared out, roughed out. I'm gonna measure that hole. These are called telescoping gauges. So all you do is you put this in the hole and get it all centered, straight up and down. And all you do is you tighten this. And you can kind of feel it. And that's good. Probably get like within 1 thou with these. So the idea, I just want this to be probably within 1 thou. That way it's a decent fit. So this measurement is 1 inch 693. So we want this to measure exactly the same. So this is 1 inch 691. So what that means is we're gonna open up the bore by 2 thou more in the computer. But it's the inside of a hole, so we're actually gonna do 1 thou in the comp. So right there, tool 6, tool 6, and here we go. Two passes. Alright, we're back with telescoping gauges. Telescoping gauge. So, center it. Little wiggle action, straight up and down. Right there. Tighten it. So the magic number is 1 inch 693. And it's at 692. So we're gonna do one more thou and then we'll call it. We'll do negative thou and 2/10. All right. So cooling off. We'll let that finish. Wow, there she is. Thing came out awesome. Alright, we're gonna make a line and cut it right down the middle here. The bandsaw, and then we're gonna tap this side and we'll be good to go. can kind of see it. Blue Dicom's better, but the red works all right. All right, let's cut this thing up and then we'll tap it. Just gonna try to start it like this. It's kind of a big tap, so I don't know how it's gonna go. Not very good, clearly. Alright. I'm gonna do it by hand. Tap magic is magic. Should probably take that end mill out of there so I don't get cut. Okay, that started. Main thing is just getting it started straight. It's the main mission, but this thing is pretty good, so as long as you good amount of pressure on it. Once you get it started, it's cake. I like cake. Alright, let's send this bad boy through there. So this actually has a ratchet, which is really cool. Check that out. It works alright because you're supposed to go forward and back when you're tapping. So it's really better if you just leave it regular, but gonna pour a little more of this down there. Stuff is magical. It's called tap magic for a reason. If I was going to produce these, I would definitely thread mill them. That way, I don't know if anybody knows what thread milling is, but pretty much you have a little sharp round tool that's the same size as one of these threads, and it just goes in and goes up.